John Frederick Daniel was born on the 12th March 1790 and died on the 13th March 1845. He was an English chemist and physicist. Daniel was born in London. In 1831, he became the first professor of chemistry at the newly founded King's College London. His name is best known for his invention of the Daniel cell, an electric battery much better than voltaic cells. In 1840, he erected in the hall of the Royal Society a water barometer, with which he carried out a large number of observations. In 1842, he was awarded an honorary doctorate of civil law by the University of Oxford. The Daniel cell is a type of electrochemical cell invented in 1836 by John Frederick Daniel and consisted of a copper pot filled with a copper 2 sulfate solution in which was immersed a container filled with sulfuric acid and a zinc electrode. Zinc sulfate may be substituted for the sulfuric acid. The Daniel cell was a great improvement over the existing technology used in the early days of battery development.
With an experiment, we will try to make or build an electrochemical cell just like the one Daniel did. For this, we will use two beakers. In one of them, we will put a solution of copper sulfate and in the other zinc sulfate. We will need two electrodes, a zinc electrode and a copper electrode, two wires, an electrode holder, and a salt bridge. Finally, we will use an ammeter and a lamp to look if there is or not a tension.
First, we prepare the salt bridge with potassium nitrate and we put the two electrodes in a support to hold them. Then, in one beaker, we poured a solution of copper sulfate and in another a solution of zinc sulfate. Then, we put both electrodes in the beakers. The copper electrode in the first beaker and the zinc electrode in the second beaker. Finally, we dipped a tip of the salt bridge in one beaker and another tip in the other. In order to measure the electrical current, we connected wires to both electrodes and a lamp. Since the lamp didn't light up, the current wasn't strong enough. But there was an intensity measured by the emitter, an intensity of 0.012 milliampere. The equation of the reactance is Zn and Cu2 plus is equal to Zn2 plus and Cu. The electrical current comes from a transfer of electrons during the transformation. We can see that electrons are given by zinc to the copper ion. Since the zinc transforms into the ion, Zn2 plus. In this case, electrical energy is converted to chemical energy.
L'autre, j'en mettrai un tout petit peu plus.
Ah bah du coup, on a un peu de sulfate de cuivre, donc le cuivre. Oh, voilà.
Ça tu comprends, hein?
Ça a rien passé.
Par contre, il y en a un qui est plus bas.
Bon, c'est quoi qui va dans quoi?
Le cuivre va dans le sulfate de cuivre. Le zinc dans le sulfate de zinc.
Ah, moi j'avais mis.
Voilà, comme ça. Et ça, mais ça là est plus ça, faut pas que ça touche, c'est ça?
Faut pas que ça touche les plaques. Tu peux tout toucher sauf les plaques.
electrical energies are necessary in our everyday life and in our activities. We know two types of usage. The specific usage, this is the usage that only electricity can provide now, phone, electronic, computing, lighting, etc. And the substitutable energy. This is the usage that can be assured by other energy sources, the heat and the fuel motors, gas, hydrogen, air conditioning, etc. This electrical energy is used in many sectors, like the lighting in the tertiary sector, in the household equipment, in the industrial application, in the health and the security, and in the domestic